Okay, welcome to your videos on circle theorems exam questions. When I'm looking at an exam question on circle theorems, the first thing that's running through my head is a little checklist, right? And the first thing in my head is, what circle theorems might I need to use? And my second thing in my checklist in my head, or you could even write this down, is any other geometrical information. So any other geometry facts I might need. And you can kind of look for clues. It's a bit like being a detective working with circle theorems. Any other clues in this? So straight away I'm noticing that there are tangents. And I'm noticing that there's this radius with the tangent. So when there are tangents, there's a few things I know. Firstly, I know that that length is equal to that length, and I can show that with little dashes. The other thing I know is that if there's tangents and radii, they're 90-degree angles between them. So I can put in two 90-degree angles. And the third thing I know is that the alternate segment theorem can involve tangents, but I haven't got any triangle in here, so I know it's not going to be a alternate segment theorem, or it probably won't be, unless I have to create the triangle for myself and so on, but don't assume that to begin with. So I've used some circle theorems. I've thought about which ones might be relevant. Any other geometry facts? Well, big clue, I've got parallel lines. So in this case I'm thinking, right, parallel lines. And I've also got some triangles and some quadrilateral, a kite there, quadrilateral, a kite, and I've got some parallel lines that I might need to use, so alternate or corresponding angles. That might come into play. And that's before I've really looked at what the question's asking me to actually do. The question's asking for SOB, the size of angle SOB. So here's my angle SOB. That's the one I'm trying to find. And I need to be a detective going at it. Alright, and this is the way I'm going to do it. I'm thinking this triangle here. Right? And I'm going to use that. But we'll see how I do that. The first thing is, I know that this is 22 degrees. Because the line between the center of a circle and any point outside will bisect the two tangents. So it's right in the middle. So that's 22 degrees. So that's good. And I know that's 90 degrees. So I've nearly got enough information to find out what this, or I do have enough information to find out what that whole angle is. Right? So angle SOP, that's the whole angle there, equals 180. This is just angles in a triangle. So this is another geometry fact I need. Take away, what have I got? I've got 90 and 22 already known. 90 plus 22. Okay, which is 180. Take away 90 plus 22 is 112. Right, and 180 take away 112 leaves me with 68 degrees. So SOB is 68 degrees. Angle SOB. That's all of that. But I don't have enough information yet because I need to know what that is. And hey presto, here is my, I know that that's also 22 degrees, and I'm going to use my parallel lines fact that I thought would probably come in handy. That is an alternate angle. Remember, Z angle, alternate angle with that, so that's 22 degrees. So SOB is the 68, is SOP, take away this. So angle SOB equals 68, take away 22, which is 58, 48, 46 degrees. And that's question 1.